something which I think we normally don't talk about in pulp and paper-based exhibitions and seminars. I don't know why Ivan chose me to talk here, but when he chose me and he asked me, what can you talk about? I said, I know very little, but I'm passionate about something and I can talk about that, but I have very little knowledge in that. So thanks to you, Ivan, actually I could read a lot in the last 3 months in this area which I'm going to discuss with you. I'm actually really happy that it's a small group. Because that means that we can interact a lot more. Because I'm going to need a lot of help from you. Is that okay? Yeah, because we're going to have more of an interaction than a one-way street. Because mostly because I know lots of you here are much more knowledgeable about packaging and about paper than me. So I'm probably going to leave a lot to you than actually talk about it myself. So there is a famous quote on the screen. I'm sure you all can read that. It says, I think the biggest innovations of the 21st century will be at the intersection of biology and technology. A new era is beginning. Who do you think said that? Who could have said that? Ah, somebody said it. Well, somebody said Steve Jobs? I did not expect that. Well, somebody did say it. I think somebody read it before when I was trying to plug it in. I did not expect that. I thought there'd be more of a discussion on this. But even a great visionary like Steve Jobs believed that there is going to be a lot of biology that will get merged with technology. And that's the fundamental idea of my talk today. So the talk, as you would read, says a word called biomimicry. So what do you guys think biomimicry is?
Imitating nature.
Absolutely. So can we have applause for the lady? So biomimicry, of course, as the word says, it's fundamentally imitating nature. So now nature, if you look at nature, nature has a lot of experience. It is from the first bacteria that emerged about 3.6 billion years back to present, and the kind of intricate structures that we see in the nature are totally amazing. And of course, one of them is on your screen. And it's not just the butterfly that is there on your screen. There's the whole idea of the colors in the butterfly. Also to do with the way it is structured. If you see, the black is nearer to the body and the white is on the behind. It's to absorb heat and to dissipate heat. A lot of technology today is actually being evolved looking at different things in nature. So even if you look at the butterfly, the color technology today in the TVs are being actually utilized from the way the butterfly gets its color, which is far deeper than what was there in our picture tubes before. So first of all, I think I'm going to give you some ideas just to open up the minds, not from packaging, but generally from the world. What is happening in terms of biomimicry? How are companies actually copying nature, looking and observing nature, and trying to come out with products which are different from what they were, and actually much more functional. So people were mentioning, we were talking about Japan earlier, and of course we all know the bullet train there. Do you know that the whole design of the bullet train came from the beak of the kingfisher? So that's amazing. But the designers actually studied the way the kingfisher's beak was, and that's how the whole train came about. Ariana before me mentioned honeycomb design. Now honeycomb design, of course, anybody in packaging knows it. Anybody who's in the corrugation business, in the craft business, knows honeycomb. And it has become totally prevalent. And we know the kind of strength a honeycomb adds. Of course, where does the honeycomb comes from? From these little creatures there which give us the beautiful honey. And there are numerous things we mimic from the bees, not just the honeycomb design, but the way their processes work. There is a lot of process mimicry that also happens from honeybees. And of course, you see there, it's not just the packaging, it's also places to sit. On a very little sort of material, you can create a fundamental structure which can support a lot of weight. A leaf, a simple leaf. If you see the way the leaf is actually can turns and becomes like a ball, there's a tent that is now being designed and actually available in the market based on that leaf structure. Numerous other examples, so let me go through one of them. The humpback whale, if you look at its flipper, there are turbine blades which get designed based on that flipper, the way the humpback whale is. Of course, all of us have been scared at some point or the other when at night a cat has stared back at us. And beautiful eyes, and they reflect in any sort of darkness. And a lot of reflectors today mimic that technology of the eye of the cat. Of course, the very famous Beetle car, which was called the Bug somewhere and Beetle other places, and of course it was Volkswagen fundamentally looked at the Beetle and worked on how it can copy that. Very interesting again. You look at termite molds, all across jungles of Asia, in India especially, we see so many of them. And today there are buildings being designed because they're such amazing creatures. These little termites create such huge structures from the outside and intricate structures from the inside. And they're so strong. How can you mimic that in our buildings? And there are buildings actually being made today to mimic that structure. Very, very famous. I think everybody knows this one and has used this one or probably uses this one, a Velcro, which was actually came about by a famous scientist. I think it was a Swedish guy. Does anybody remember? I actually have forgotten. I was trying to remember this morning where he was from, but I think it was a Swedish guy who was walking along and he got burr on his clothes, and when he took them off, he thought, this is an interesting process on how they hook themselves to clothes, and how you can utilize them in a simple process like closing and opening something. And of course today Velcro is prevalent in all sorts of things, not just shoes or clothes. This is a very interesting drone that is now being designed based on a bat's wings, the way the bat flies. Beautiful. The elephant's trunk. We are in Thailand, we have lots of elephants. Back in India we have lots of elephants. Robots being designed based on the trunk structure of the elephant. How the elephant's trunks works. The same way a robot is being designed by the bone structure of the trunk itself. Solar technology today, everybody talks about renewable energy, and part of our passion in my companies is also to do with to renewable energy. Ivy. Ivy is a freestanding plant in nature. Now these, so of course, otherwise you need structures to set up solar units. So these panels have been designed. Individual panels about 80 kilowatts is what they generate, and they are being designed as freestanding panels based on ivy sort of structures and the lightness of the ivy. Have you seen weird looking people running in these shoes these days? Do you know where they come from? The sole? It's the gecko. The gecko, or like the lizard, it's not the same family, but the gecko has feet like that, and it has wonderful grips on its feet. And that's how the design of the bottom of that Vibram shoe came about. What is that?
Camel.
Come on, you guys can tell me what that is.
Camel.
It's a camel. Camel, of course, we all know that the amount of distance it can cover in the desert, and without water. Of course, it stores water. The great thing, and he can do that in that crazy heat, 50 degrees Celsius or more of the desert, fundamentally because of the way he breathes. The camel breathes. The camel, the way the condensation takes place, it cools down the camel. So scientists studied this whole process, came out with something that would mimic the camel's breathing, and designed something like this in Qatar. The whole building structures without air conditioning in the middle of the desert, based on camel's breathing. So there are amazing things, mind-blowing things actually happening if we look at nature, because nature has so much experience. 3.6 billion years of evolution, trying and testing and removing things which are not needed, keeping things which are needed, evolving things better, making things better every day, and coming out with, absolute solutions for everything. Nature has all solutions. We only have to open our eyes and look. But the question is, how does it apply to us? We are sitting in a pulp and paper, Asia paper conference. The previous speaker talked about packaging. Do you think this can apply to us? Do you really think so? I see very little knots. Maybe, maybe not. It absolutely does. Packaging is everywhere in nature. Don't you think packaging is everywhere? Anywhere you look, there is packaging. Nature packages wonderfully well. And I'm going to remind you that. First of all, I'm going to remind you by this picture. The best packaging we all have. This beautiful skin. Breathable, waterproof, what else? All sorts of things in the skin. If you look at the skin itself, it's an amazing creation. And there is so much to learn just by looking at ourselves in packaging. And it's keeping a lot of things inside us. Holding it all together, making sure outside doesn't come in, inside doesn't go out. All that. All that we try and do by packaging, protecting, cost effective, relatively. So the skin itself is a natural packaging, which is amazing. I'm just going to give you a few examples. I'm sure there are millions of examples you all know, but just some things I thought of and put it across, and to give you a wide variety of things nature packages. Not just to give you, again, just to open up your minds a little bit, how nature packages, because we have to start looking at it for reasons I'm going to talk about. It's an absolute must that as part of the packaging industry, we have to start looking at nature. We talk about environment, but environment is not just about recycling. Environment is about creating less waste at the first place, creating it with less energy at the first place. So, so environment is a lot about that rather than the whole talk about just recycling or being recyclable. Flexible packaging is not recyclable, and hence it's bad. That's not the question. That's actually a step ahead. So you look at peas, beautiful structures, small balls kept in this pod, beautifully designed. Again, perfect to the, perfectly fitting to these things inside it. Amazing. Coconuts. A tender coconut, a fully grown coconut, liquid packaging. We talk about all the issues with oxygen transmission rate and water vapor transmission rate and all that sort of thing. Look at the coconut. It keeps something which is so delicate as the coconut cream inside, which grows into a thicker product. It also keeps inside liquid, absolute pure sort of watery liquid inside without any leakage. Have you ever seen a coconut leak in the tree? Rare. I don't think, at least I have not seen it. But any packaging that you have, when we talk about protection, somewhere or the other it's going to fail, but not the coconut. So again, amazing type of packaging that has been evolved in nature. I'm always amazed by pomegranates. They're such delicate fruit. If you look at the seeds and squish the seed, there is nothing in it. But look at the intricate structure. You don't even have to put it in a box. You can just throw it in a truck and take it away. And nothing will happen to the seeds. Because of the outer cover, the way it is structured, the way the fiber structures it in terms of the hexagonality of the whole thing, you can look at the internal protection, the skin on the inside, the way it protects and separates each seed from the other so that one seed doesn't squish the other. So there are both aspects, external force and internal force. Both are being taken care of in the pomegranate, not just the external force. Perfect to the fit. Sometimes when we pack, we create these beautiful boxes, and there'll be a box again, and inside the other there'll be a pulp mold, there'll be a thermocol or a sort of polystyrene thing inside which will protect a mobile phone. The mobile phone is this big, the box is that big. So these days they've started making it a little smaller. But we create so much space where it's not needed. But look at the banana. The banana's fruit is here, the covering is right on top, perfect protection. Again, you can transport it, at least where I come from, they're just put into the truck and they go away. There are no boxes required for bananas. So again, beautiful fiber structure if you study it under a microscope, absolutely stunning. Can anybody tell me what this is? Seafood people, similar family.
Mussels?
Abalone. Yeah, I think some of you eat it. I'm a vegetarian, so I don't actually eat abalone. But the meat is supposed to be good meat. Who knows who's eaten abalone? Ivan has. Is it good meat?
Yeah.
It's good meat, but what is even more interesting, do you know the protection? The cover, the shell of the abalone is 6 times stronger than the strongest ceramic the man has made. It's that strong. You cannot break it. So it's amazing what again nature has created by accumulating calcium and proteins together. And of course, you know, Ariana talked about it. There is soft packaging and there is hard packaging, and nature does both, as you are seeing. There is coconuts and there is abalone, and there is another thing which is going to come after this, which is all hard packaging, and then you have the pomegranates and the bananas and everything else, which are more sugar sort of cell oriented structures, cellulosic structures. Cellulosic structure and protein oriented structures, you know, both are available in nature. But amazing, abalone is totally amazing as a packaging. Do you know what this animal is? Armadillo. Look at what it does when he feels danger. Armadillo makes itself into a ball. You know, it's amazing. You can kick it literally and it'll roll. But that's how nature has made it. You know, it can package itself into a ball. So the flexibility of, again, natural packaging. And of course, we know the armadillo skin itself is a good, good packaging source. So this is what I was talking about, hard packaging. You know, an egg a day sort of concept. You know, people promote that. Wonderful. If you squish it from the vertical side, what happens? I'm told it won't even break if, you know, something really heavy went on it. I'm told even a truck. I'm not so sure about that. But I'm told that, you know, if you compress it like that, it will not break. That's the way the fiber structures are, not the fiber, but the structure of the calcium is in terms of the eggshell. But if you want to break it on the side, you just go tuck, 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 and open. So again, what a beautiful way nature is created to protect the living life inside a shell. So what does nature do? You know, I've tried to give you a little bit of a background to open up the minds and to see, you know, what is happening in nature. But how does nature do is, what does it really do? That is important. If you look at nature's process, it is very life-friendly. It sort of creates something, grows something. The whole manufacturing process is about growing anything. You know, you can take a small seed and a tall tree grows out of it, or anything grows from the small to the bottom, accumulates things and keeps growing. What do? And as paper makers, I think some of you at least must be paper makers, and I'm sure all of you are familiar with the industries. But it's not just paper making, it's any industry, it's any manufacturing in humankind. How does it happen? Do you recognize this? Cook the fiber, refine the fiber, treat the fiber. Anything else as well. You know, any other chemical industry, some of you are from the chemical industry here, my friend from Foyt, you know, making machines. Ultimately, this is how it happens. You heat a metal, you beat a metal, you treat a metal. So you know, there's a difference in the way nature is looking at things and in the way human beings are looking at things. And fundamentally, we may be spending a lot more energy and resources in our manufacturing processes than what actually nature does. And who comes out with a better substance? Nature or humans? You know, it's evident from the packaging that nature does come out with much far superior, we can call it God-oriented, substances with beautiful colors. We talked about colors in packaging. You know, we look at different, organisms and look at the beautiful colors you have in nature. It's very difficult for the pigment guys to actually do that, and pigment guys do struggle with it day in, day out to create those beautiful colors. So instead of, so I was thinking about this presentation, and I was thinking, how do I, because this is what we are trying to do in our companies at least, when I'm here talking to you, I'm trying to bring in a mindset shift. So I was thinking about how to bring this whole mindset shift idea. When I actually, and I came out with maybe 10 different examples. And I said, let's give different examples of how it is already happening. You know, I'm not just talking about something that's very, very far away. I'm talking about things which are happening in the packaging world. So I said, they are of course happening in numerous other examples I gave you, but they are also happening in the packaging world. But instead of just looking at one aspect of it, so I could pick up a bag which is based on the armadillo, or I could pick up something else which is based on one product. But it may not be, in the process, it may not be utilizing all the things we have talked about. So instead of taking too many examples, I actually took two which I'm totally impressed by, and they totally fit what we've been talking about, and will create a mindset shift. And I'll have to give due regards to people who are actually creating these processes. So this is a guy called Andres Forgax, and you can actually Google him, and there's a beautiful TED talk from Andres. And he's created, what does he call it? It's like a biomimicked leather. What he's created is, fundamentally, the idea is of cell multiplication. If you take a tissue from anything, say you take a tissue, which is not painful, you take a tissue from a cow, and you take a cell out of the tissue, and you multiply the cell. Nothing that is too extraordinary. Same thing as the way you create beer, the way you create wine, the way you create yogurt, similar cell multiplication sort of system. And then you grow those cells, and you create sheets out of it. And this is actually being done. Yeah, this is not story. This is actually being done. It is available in the market. And where does this come from? If you look at our population growth, we are bursting at our seams. Today we have 7 billion people, as Ariana said before. And we are going to be about 10 billion in 2020 is what they say. We've got such a huge meat-eating population. We have about 60 billion feedstock in our world, which are trying to feed humans. How are we ever going to be able to bring that 60 billion to maybe 80 billion or something, 100 billion to actually feed 10 billion people? So that's a huge challenge. So eventually the idea is, how do you grow meat instead of slaughtering meat? Instead of killing animals, how do you actually start growing meat? But of course, making people eat an artificial substance is difficult. So we are starting with packaging or leather, is what this company is starting with. So basically what it does is, fundamentally after growing the cells, it grows sheets, it compresses sheets, it cuts and dyes if it's required, and finishes it. But there are a few interesting things here. You don't have to grow sheets in flat rectangular structures. You can grow it in the shape of a wallet. You can grow it in the shape of a shoe. It's not like when you kill a cow and you take a cow's hide and you have to cut it to different shapes, and there's lots of wastage. You take an alligator, there's a lot of wastage, again, from the crocodile skin that you take out, because that is not going to be exactly fitting to the way you want to make your wallet or your shoes. You're going to have to cut from that. Here you can grow the cell structure in the shape you want, so no wastage, similar to nature. There's no wastage in nature. You basically create it in the shape you want it as the final product. The other thing which you can do is that you can make a soft leather, you can make a hard leather, you can make a thick leather, you can make a thin leather, you can make it paper thin and with different properties. It's similar to what we do in our mills, with different GSMs, different thicknesses, different sort of stiffness levels, all that you can do when you're actually manufacturing. But the whole idea is no wastage and growth. So this is a wonderful, and I would really encourage you to have a look at the whole talk, because it is amazing what they're doing. A company that has become a friend and we've been conversing for some time, a company called Ecovative, again, Google that, and they've created something called Eco Cradle. Now my friend Eben in Albany, New York, small town, was walking in nature and found moles growing on trees. And what do moles do? What does fungus do in nature fundamentally? Breaks down substances. Yeah, basically it's breaking down something in nature. So they saw moles growing, and he said, how can I adapt that to our manufacturing instead of just being growing in nature? So of course, lots of you here are from the chemistry background. We know that mushrooms fundamentally have mycelium, which makes the molds grow. So they took mycelium as an enzyme, took some lime, took some fiber, created the molds that they wanted, put it inside, put some water, put moisture in, and let it grow. And in 4 or 5 days they had the mold they wanted. All you needed to do was dehydrate it for it to stop growing. Because of course if the water is there, it will keep growing. So you have to stop it from growing. But that is what they did, and they came out with a beautiful substance which is an excellent replacement for polystyrene. And polystyrene is dangerous stuff because it doesn't recycle. If you burn it, there's noxious gases. So instead of polystyrene, we have something called eco-cradle, which actually you can use in fast-moving consumer goods. There's a wine bottle. You can do it for fridges. You can do it for computers. Anywhere thermocol is used, you can change it to. They're even making tables actually with a hard exterior with the eco-cradle, very, very light. But the other thing, and again, somebody asked, I think you asked Ariana about the cost idea of this. This is actually almost cheaper than polystyrene, which is amazing because replacing plastic otherwise. And of course, we talk to manufacturers all the time. We talk to consumers, converters, and to FMCG companies all the time. And yes, there are two questions always in the end. You can talk all about nature that you want. You can talk all about environment that you want. You can talk all about recyclability all you want and ecological packaging all you want. Final questions, two. Performance, first question. My substance should not, and I was in a conference, PaperCon in the US, and they were very clear. Ultimately, the biggest environment damage is that if my potato chips go bad, because there's a whole life cycle behind that. So first thing is your packaging has to protect. There is no question. Performance has to be there. It is underwritten. You cannot compromise on that. Second, cost. It's again a fundamental idea is that they are in a competitive market. If they increase their cost even by 10 cents or something, there is a problem. Because the other guy is not going to follow suit. Either there's a regulation which says everybody has to shift from flexible packaging to XYZ, then everybody has to shift the entire cost structure of because what you asked was, will people, buy it? People will buy it only if everybody is selling it at that price. If there's one company which is charging a premium, maybe through branding and through marketing and through this whole, push, like the organic food push today, there might be some consumers which might pay a premium, but not the whole janta that we have. It has to be, it will be a significantly small consumer base because everybody will look at cost. So these guys have again broken that mold that you can create an ecological packaging at a lower cost and and you put it in environment again and it's gone. In a few days, it is back to nature. There is nothing that is left in this case. It's completely compostable and of course biodegradable. So how do we do this? What is the whole, how can we actually go ahead and do? So first thing, of course, like I said in the beginning, think out of the box. Second thing, we have to observe nature. There's lots of wealth there. We have to start observing it. Just open our eyes. We have to think sustainable. We have to believe in sustainability. There is no other way. We are going to kill this earth if we don't do it. And we, as part of the packaging industry, have a huge responsibility. It is not just a question of meeting the environmental regulations and supplying people with something. It is a question of being sustainable for the world ahead, for our children and for their children and their children. So of course, the basics of any natural substance is proteins and sugars in the end. We have to understand those compositions and the cell structures that are there in proteins and sugars and not limit ourselves to our cellulosic, we don't really even go into cellulosic structures. We basically more or less limit ourselves to fibers. We don't even go below fibers. Maybe people like Mr. Maheshwari do, but most of us in paper mills will not even talk more than fiber. And even in fibers, we limit ourselves to maybe softwood and hardwood and things like that. Market needs, like coconut understands the market need that it has to take a liquid across much distance. We have to collaborate. We just now still function in silos, and the maximum collaboration we do is within the industry. We have to move beyond. We have to look at researchers who are doing such amazing work. We have to look at students, as my previous presenter was mentioning. We have to look at ideas which can come from anywhere. We have to look at those and find a way to bring everybody into our whole industry. So I'm going to skip this. This is a basic spiral which they say is how to come out with a biomimicked product. And why should we do it? This is the last slide, Mr. Patel. No question, sustainable, and we need sustainability. Please believe me, recyclability is not sustainability, and especially if you're transporting fiber all the way from America to China or to India, which is what most of us do. I don't know what you do in Thailand. But we ship the material, we collect the material in America or in Europe, and then ship it all the way to China and make paper there and ship it back many times to America. That is not sustainability. We can fool the public, but we cannot fool ourselves. Sustainability is when you sort of actually produce a substance which doesn't require that much energy, which actually biodegrades, doesn't create a huge carbon footprint. We have to eliminate waste. Even in our paper mills, 6 to 7% finishing waste is taken for granted. Waste during the process, a lot of it happens. So our yields are typically 45% in terms of when we look at wood or agro waste. 45%, so you take 100%, you actually use only 45%, you waste the 55%. And after that, it's even worse when it goes to the converters. Converters typically have 30, 40% wastages at times. So, actually what you are taking from nature and which you're giving is almost 10%, actually. In the end, what the consumer gets is 90% wastage in the cycle. We have to eliminate that. Nature doesn't do that. It utilizes everything that is there. It has to perform well, no question. It has to actually cut material costs. It doesn't have to increase material costs. It has to save energy. Nature, as you see, uses solar. Everything is solar in nature. It's solar and it's water from the clouds, and that's what it is normally. That's how nature works. It doesn't work with extra energy being put in. We do tend to, when we grow things, we further put petroleum through fertilizers and things. But otherwise, if you look at biodynamics or the way the nature works, it uses solar energy mostly. And of course, we have to define through, like you saw 2 examples, we have to define new product categories and industries, and that also links in with the whole idea of thinking out of the box. It will drive revenue, believe me, when you actually go ahead and do this. It is not a revenue, it will not reduce your revenue in any way. And of course, it will build your brand, because we are still at this place where we can actually change this whole thinking, and people are getting aware. We are getting a lot of questions. I overheard that yesterday there was a lot of talk on environment, so it's on our minds. When we go for campus interviews to students, we hear it all the time. People talk about environment, and there's a huge awareness. There's a lot of environmental, spiritual, awareness of all kinds in the generation which is coming in, and we can build that brand. So another saying, who said this? A world full of wonders is let's just open our eyes. Come on. Okay, I'll give you the answer. I did today. So thank you for your time. I hope I wasn't too long or boring, and I hope some of us can take something back.